Hi guys, welcome back to LeetCode with AK. So I'm Aravind here. So yesterday we talked about the tallest billboard problem, right? So this problem was tagged as outside. Okay, just yesterday we just figured out the recursion and backtracking way to solve this problem. And today we are going to talk about how we are going to solve this problem using dynamic programming. I mean, optimize approach. Because okay, let's move on to the recap. So what we have to do, we have to actually in problem statement they will give the rod length with a given array. The only thing is like we can build all together in any different possibility, but the only thing is like we have to figure out the largest possible height of your billboard installation. This is what actually we saw in previous lecture. Actually, before guys, one thing actually I request you to everyone before you are watching this one, please watch the part one. In part one, actually I clearly explained how to solve this problem using recursing and backtracking because for solving any problem using dynamic programming, recursion and backtracking is really very important. Without knowing recursion and backtracking, definitely we can't able to solve any problem using dynamic programming. Okay, let's move on to this process. Okay, already we discussed about how to solve this problem using recursion and backtracking. Okay, then my question is like, okay, the problem is can be solved by using recursion and backtracking. So I just want to find out the optimized approach. Okay, we can able to find out that. But one thing is like, okay, before if you're solving any problem using recursion and backtracking, after solving that, just ask two questions to yourself. Then if you got the answer for the two questions, then definitely you can able to figure out whether the problem can be done by using dynamic programming or not. The very first problem is there optimal substructure. The very first question is there any other optimal substructure, and is there uh, any overlapping subproblem? So optimal substruggle is nothing but actually in regression and backtracking. What you're saying, the very first time you're picking one and you're not picking, you pick rod with a length of one and you're not picking. And the very next step, you will pick rod with a length two and don't pick. Actually, what you're doing in every step, you're picking or don't picking. So there is some sub problems, right? So there is some larger problem. What you're doing, you're in recursion and backtracking, not only this recursion and backtracking, but every recursion and backtracking. So what you will do, for huge, there will be the huge problem statement. You will simply split it into smaller sub-problem, and then finally, the lastly, once you solve that the smaller sub-problem, it will be added into the previous result. Added the result will be added to the previous the sub-problem, and then it finally all together and cumulative will solve the huge problem. Okay, so definitely there is optimal substructure is available as well as is there any other overlapping problem? Yes, there is some overlapping problem. I will tell you. In this case, just you are picking one as well as once you come to this place, you will pick two or don't pick two, as well as you will pick two or don't pick two. Meanwhile, in this step, you will pick three or don't pick three. So this is applicable for all with index of two. There is some problem. Actually, we are doing again and again. Okay, again and again for the same kind of same length of rod. Okay, my question is like, okay, I will give you problem 1 plus 2 equal to what's the result? 3. Okay. Again, after something, again, I am asking what is 1 plus 2? You're telling 3. You already did the calculation for 1 plus 2. But my question is like, you already performed the operation, right? Then why you have to perform the operation? Instead that, you can store this result somewhere else before doing any operation on future. Just check 1 plus 3 is been already done or not. Yes, it's already been done. Instead of doing any operation, it's already been done. Actually, I stored it in somewhere. Instead of doing operation, I can straight away get that value. So that is what we are going to look. Is there any other overlapping some? Yes, there is some overlapping some ground. We are again solving the same kind of sub problem in this recursion tree. Instead, that what I plan to do, why I have to solve the same problem, sub problem again. Instead, that actually I will store the result of all the sub problem in one particular array or somewhere in ASMA paraset, whatever. Okay, before I'm going to solve any sub problem, I will check whether the subproblem is exists or not. If it is exists, not a problem. I will take straight away. Actually, I will take it from my array or aspect any data structure. If not, then I will perform the calculation. So these two questions actually you should ask to yourself whether is there any other optimal steps there. Definitely for all the recursion and backtracking, there is some optimal steps there, as well as try to figure out few of these recursion and backtracking. We may not have overlapping subproblem. If the particular problem doesn't have any overlapping subproblem, then the particular problem definitely not possible to solve with dynamic programming using memoization technique. Okay, now I got the answer for these two questions. Okay, what is the next step? Then if you get the answer for these two, then definitely you got, okay, this problem can be done by using dynamic programming. Okay, I'm pretty much okay with that. Then what is the next step? In dynamic programming, memoization approach, the very first step is just understand the constraints. Just understand the constraint. The reason why I'm saying understanding the constraint, if you know what is constraint, then definitely you can define your DP array. I mean DP array. So why we have defined the size of the DP array? Why we really need that? Because in each step, actually, I'm trying to solving some subproblem. Actually, I just want to store that in somewhere. Before actually I'm going to store that in somewhere, definitely I know the size of the particular data structure. I can create any n cross m or n square, whatever structure, but that is not a good thing. Instead, there will be some consent maybe given in the problem statement. Just analyze that. So based on the consent, what we have to do, we have to create the dynamic DP array, the size of the particular consent. And once that is done, what we have to do is very simple. Just store this. What we are doing, we are adding the rod to the right part, as well as we are adding the rod to the left part, and we are not picking anything. Then finally, we are taking the maximum of all the stuff. This is what the results of one of the subproblem. Just we have to add this result to our DP array. Once the result is been added to DP array, just before performing this operation, just check. Okay, the particular operation is check. The particular operation is being done or not. That's it. Done previous. Okay, very simple. Okay. 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 First, I have to understand the constraint. Okay. Let's move on to the problem. Just understand the constraint. This is the constraint. It's been given in okay, what they are trying to say, the rod length, the array length might differ from less than or less than or 1 equal to 12. I think so. So the given, so there might be possibility at the rod array should have 20 possibility. I mean 20 different set of different or same set of rod will be available. Okay. So what about sum? I mean sum is nothing but the summation of there is two tallboard, right? Two tallboard, right? The summation of one particular tallboard. I mean left part or right part. So left part or right part may resides between 0 so what they are saying, 0 less than or equal to 500, as well as there is a right part, left part, right? Okay. So what I have to do, instead of keeping the two rod length, what I can do, I can get a difference of these two, right? So for example, if the left, for example, let's say, consider this way, if left part is length of 2 and the right part is length of 2, I don't need to keep these values. Instead, that just keep the difference. What is 2 minus 2? It's 0, right? So that will be more than enough, right? If both left part and right part is same, I just take the difference of left part and right part. If the difference is 0, then definitely these two part, left and right, both are same, right? So I need that one. So if you're taking the difference, actually A minus B or B minus A, in that case, what is the possibility? It might resides, the value might reside, because why I'm saying minus 5,000 and plus, in some case, A might be 0 and B might be 5,000. In some case, A might be 5,000 and B might be 0, right? So definitely this would resides minus 5,000 to till plus 5,000. Okay, now I'm pretty much sure about my constraint. Then what we have to do? We have to define the size of our DP array. Definitely my DP array would be two dimensions. I'm going to declare the two-dimensional DP array. It would be the size of 20 and 2 into 501. Why really 5001? Because how many elements is inside between 0 to 5,000? 5001 element. How many elements inside between minus 5,000 to 0? 5001. Okay, that is two different set. The very first set might have the possibility of 5001 different possibility, and I left might have possibility of 5001. So that's why I'm going to create a two-dimensional array. The very first part, I mean this part, I part, may reside between 0 to 20 because it will clearly illustrating different types of rod length, different types of rod length. Okay, as well as this one defining the possibility of summations, right? Possibility of difference between left and right part. Okay, this is my size of the DP array. Once this is done, I'm pretty much sure there is that it doesn't require much code changes. Only you have to define this is our, okay, just define, okay, once that is done, yes, equal to, okay, okay, fine. Okay, I just defined the DP array. Then what I have to do? Definitely, I have to pass my DP array to this recursive call. Okay, I don't need a left part and right part. Instead, that actually I need a summation. So what I will do, I will take the sum and I will take the DP array. Okay, the very first time actually I will check that at the index equal to then the sum, then check. In this case, actually I don't have left part and right part. Simply said my summation equal to 0. If it is equal to 0, then return 0. Otherwise, simply return the minimum possible. I mean the minimum possible number value. The minimum possible number value is number dot mean value. Don't worry about that. Okay, I will share this code to comment section. Definitely you can get it over there. Okay. Then what I have to do before performing any operation, what I say, okay, you need first you have to figure out understand the constraint and just define the size of the deep array. Then for performing uh, every subproblem, just check it's being done already or not. If it is done, if it is done, add it to DP array. Otherwise, simply perform the operation. And finally, you will get some result, right? So if you are performing operation, definitely at the end, you will get a result. Add it to DP array. Only then actually I can able to use that in near future if somewhere actually I am trying to perform the same operation again and again. Okay. This is what actually I'm going to do. Okay. Check the DP array. Okay. If DP, a DP of, okay. Okay. DP of, I, some plus 5,000. Not equal to minus 1 because I'm initializing my DP array here in 5,000. I'm just checking it's a 5,000 or not. If it is 5,000, I mean minus 1 or not. If it is minus 1, if not minus 1, just return this because this has been done already. Don't do again and again. You will get it stuck. I just want to reduce the time complexity over there. Okay, I'm just increasing the index as well as I don't need this stuff. Instead, just pass my DP array. Just pass my DP array. Okay, I will implement the index. Okay, okay. Simple. Okay. So the problematic approach very really comes to here. The very first option actually I have to add it to left part. I'm picking the particular rod for my left part. In that case, what you have to do? You have to add this sum, right? Definitely you have to add this sum. Okay, rod of index. The meanwhile, okay, if you are picking as I said earlier, okay, as I said earlier, okay, okay, let's say this is the left part, height of the my left part and height of the my right part. Okay, so what I have to do, as I said earlier, you don't need to pick the length of these two. Okay, instead that you can pick the length of this particular or pick the length of left part or right part. Definitely that would be the answer. If this is 6, if this is 6, you're going to pick 6 plus 2, 6 plus 6. Instead that you need a height of any one of these, right? You don't need the height of both of these. You need the height of any one of these. That would be the answer, right? So what I am doing, what I am going to do, so where is my problem? Okay, and just add. Okay, this has been done already. Okay, see here, here, and just add the value of the particular rod length. Meanwhile, I will just deduct this set because I just want to perform whether both left side and my right side equal to 0. So that's why I'm adding the rod index to one part as well as I'm deducting this from the one part so that this is the these two possibilities. One is adding to the left part or right part, depends on your convenience. And meanwhile, if you're adding the rod length to one particular side, just deduct the rod from the another side. So that is two possibilities. The third possibility, don't pick that particular rod length. This is the third possibility. Okay, what we have to do, we have to pick the highest possible. We have to pick the largest possible height of the billboard instrument. So definitely we need math.max. So what I am doing, so in straight away pick math.max and return this value. Okay. So if we are definitely we have to store this value. This is the result of one of the subproblem. Okay, this is the result of one of the subproblem. You have to store this to somewhere else in your DP array. Only then this will be utilized in near future if again the problem going again the program going to solve the same problem again, then I will check the problem is done already or not. If it is done, then I will straight away return it from the DP array. So this is very simple dynamic program memoization approach. Coming back to the space complexity, the final part, the space complexity, actually I'm declaring some array, definitely will take some space. What is the space? 20 into 2 into 20 into 2 into 5001. This is my space complexity. And what about the time complexity? Definitely there is some possibility of O of n of O of rod length. I mean the O of n because this is some recursive problem, right? Definitely the recursive stack should take some space to store the recursive problem. So definitely the recursive stack would take O of n time complexity where n stand for rod, the length of rod array. Okay, that is auxiliary space complexity because once all the execution will be done, definitely the recursive card would be empty. This is auxiliary space complexity. What about the time complexity? Actually, in time complexity, definitely what we are going to do. Okay, in time complexity, just imagine I'm doing 21 iteration here. That is also one possibility of time complexity. But here in this place, okay, wait. Guys, wait. Yes. Okay. The both time and space complexity would be similar because definitely for space complexity, definitely this would be the part of the DP array. This will be the part of the recursive chart. But time complexity would be the same part. 20 into 2 plus 1 because we have to find out all the possibility for this particular space. At worst case, the rod may have 20 different possibility, as well as the summation would differ from 0 minus 5,000 to plus 5,000. In that case, this would be the time complexity as well as this would be the space complexity. But additionally, the recursive call stack would require some space. So this is auxiliary. We don't need to worry about that. Both time and space will just same for this problem. Thank you guys for stick with me till the end. Tomorrow we're going to see another interesting problem. Thank you so much. Please try to watch part 1 and part B because part 2 is very continuation of part 1. The part 1 actually we think we are dealing with how to solve the problem using regression and backtracking. In part 2 we just think about how to get optimized approach using dynamic programming, memoization approach. Please try to subscribe my channel and keep on supporting me. Thank you so much, guys. We'll meet you on tomorrow. Thank you.